Thanks, Lucy. So I'll go ahead and share my screen here. All right, so first, thanks for the opportunity to talk about the work that we're doing at Ocean InfoHub. A lot of people have contributed to the material that you see here. Also, thanks to Adam, Lucy, and Pierluigi for an excellent foundation upon which to discuss these items here. There's really only kind of three main areas I want to talk about. So we'll talk a little bit about some general concepts just to lay a foundation to build upon the presentations that you've seen previously and in the previous section. Then I want to talk about two specific approaches, thematic types that we addressed in Ocean InfoHub. That is the concept of a map as a creative work. And this is looking more at a document or a item resource that you might share on the web. The other then is to look directly at spatial geometry and how the intersection between certain geospatial standards and web standards come together in this particular project. So in terms of general concepts, schema.org and structured data on the web, I should point out initially, is not a spatial database. This does not replace the PostGIS or other environments that you're using for your spatial information, but it can carry spatial information and it can connect that then to other resources. So we've talked a little bit about the idea of connecting these resources, a graph that you can use, and we'll see a little bit more about that in a little bit. And that's a very powerful capacity to be able to connect documents with people, with courses, with events that have occurred, like maybe ship cruises or other elements. So we'll talk a little bit about that, and I hope I'll be able to show you a little bit about that in some of the examples that we'll go through. The other thing is that this approach very much is designed around aiding discovery, and there was a mention of fair data in previous sessions. And this is very much stressed on issues of findability in that fair data, but it can go further than that. And it can also move toward sharing some of those elements that we may need for interoperability, for accessing, for these types of elements of fair data. So it's a very nice opportunity to begin looking at fair data principles in this context. And because it's a graph, we can also leverage unique identifiers and persistent IDs. Those may be people with ORC IDs, they may be documents with DOIs, they might even be samples with IGSNs. And all those are very nice elements inside a graph-like structure. It's also a gateway to enhanced web presence because we are leveraging web architecture in this approach. That means that as you express in a more structured way the information that you're holding, it enables commercial indexers, be that Google or Bing or others, to better support discovery of those resources through those environments. But those same web architectural principles allow anyone to access that information. Pierluigi talked about this not being a centralized hub, but rather a distributed and federated approach, and that's very much the case. These principles allow us to create indexes that may serve a particular community or a particular region or a particular thematic that we wish to look at. And so I think that's a very powerful aspect to it. And another thing is that it's very much based on web standards. JSON LD has been mentioned, RDF has been mentioned, OGC standards are of course part of this. And so it's an opportunity to look at those standards and those recommendations and implement them into our practices. And that implementation also is a nice way to sustain the overall project as well, because now they become integral aspects of a facility or a data community's operation. So these were just some kind of the general concepts, and most of these, if not all of these, have been highlighted in the previous presentations. So the first one I want to talk about is map as creative work. And actually, within the schema.org vocabulary, and perhaps I should stop there for just a minute and pull up schema.org, but The schema.org vocabulary is a vocabulary that was created by Google, Yahoo, Bing, Yandex, several others. And it's a very high level vocabulary for describing resources. And it allows us then to have kind of a common context that we can share within our community for understanding what these resources are. And so what we've done is we've leveraged these inside the Ocean InfoHub in the description of these thematics. And one of these thematics, and we can use this to begin exploring what we've done here, is spatial maps. Now, in this case, maps are a subset of creative work or document. So these would typically be things like files. They may be KML files or GeoJSON files. They may just be PDFs describing a region. But by utilizing this, then we can begin to express metadata associated with these files. We can scroll down here and take a quick look. At what a JSON LD document would look like, and Adam mentioned and referenced these earlier. I also mentioned the RDF triple, and you can begin to see that directly inside here. When we think of a subject and a predicate connecting to an object, in this case, the ID is our subject, so we have some kind of resource that we wish to talk about, and we associate a name with that. And in this case, the name is just a textual string. But if we look at this, and this is just a quick visual overview of this, the circles then become the kind of subjects that we wish to talk about. But we can actually connect concepts through predicates. So we've connected here a concept of an identifier for a resource through a predicate to another resource that can then be further defined by more detail on that. And so we begin to develop that kind of graph hierarchy here. This is a tree structure here because we haven't looped back, on any other concepts, but we can do that within that and form that kind of graph overview. And so you begin to see, the RDF triple concept within a JSON LD document inside spatial maps. Because spatial maps, and I should mention that this is all at the bookinfohub.org site that Arno thankfully shared earlier. Because spatial maps are a subset of documents, we can begin to see some of the other elements that we can describe in documents. And though this looks maybe a bit messy at this time, there's a nice structure to this, right? We're looking at things like an author, an identifier, a set of keywords that are associated with that. And we break these down then into their individual elements further in the documentation. And what this is doing really is allowing us to create a metadata document associated with our resource that goes through these various things, whether it's things like a publisher and provider that you see here, and it provides that kind of linkage. These links may be DOIs, or they may be simple URLs or URIs that point back to online resources. They may be ORC IDs that point to individual people as well. And so these are kind of the types of properties that we can begin to associate with these resources. When we create these resources and put them into a web page, in this case, again, dealing mostly with just documents right now, and we'll jump into the spatial concepts here in just a second. But when we create these then, and people publish them on the web, within Ocean InfoHub, we're leveraging, again, standard web architectural patterns to access those resources over the web and harvest them into an index. What we've done then is created a very simple interface onto that index. And this is not a final product. That will be some further work that's coming. This is simply a reference implementation of a development environment. But I can come in here and what we're going to be doing then is we're going to be searching over a graph that was generated by going out and collecting these JSON LD documents that have been published in these pages. And so, for example, we might even look at one of these. We can pop out. In this case, you can see that this one was from ODIS. But if we go down through here, we might see ones coming from other sources. ODIS got pretty popular with this search, but there can be other ones, and I'll show you in just a moment. But if we look at this ODIS resource that we just found, we can actually go through and look at the page source that's in this. And if we look for a particular script type that was like what Adam was mentioning, you can see now we've injected or found this JSON LD document in this resource. And this was the pattern that we used to generate this, right? So a JSON LD document placed in a web page that was harvested then into an index. And again, anyone could both do that harvesting process and generate this index, but also build an interface to it or leverage the one we have here. If we begin to say, okay, well, let's look at a particular type of resource that we're after, we could actually say we want Coral, but we're looking for courses. This is a different thematic type within the Ocean InfoHub, and we can see then that that link takes place here. So let's jump back and talk a little bit about spatial data on the web, because that maybe is more interesting or more core to some of the things that are going on here. So let's take a look at the guidance that we've been working with for spatial geometry. One of the things that I should mention here is that while we're using schema.org as the primary vocabulary for describing these resources, in this case, we've reached out now to OGC's geosparql specification to provide more detailed approaches, more spatially and geometry-centric approaches to representing spatial data on our resources. In this case, you see, again, a JSON LD document, similar to the one we saw embedded in the ODIS site. In this here, though, we've added a new predicate in our triple. So again, we have our subject, our ID that we're talking about. Our predicate now is saying it has a geometry. And in this case, you can begin to drill down here and find out that, in fact, we're looking at a well-known text representation of that geometry. And of course, we can use any well-known text we want. If we wanted to use bounding boxes or things like that, we could utilize those as well. And again, we see this breakdown of identifier has a geometry. This is a blank node, simply a node in the graph that we have not identified, which is not necessary in this case. And then we've said that this is a well-known text string, and so we have its value. We have a CRS value that we can associate with it. In this case, it's a type point. And so this is the type of information that we can begin to associate with our resources. There are classic approaches in schema.org to dealing with geospatial data, and you can utilize those as well. We felt they weren't quite appropriate for the uses that we wanted to use. And another nice thing about well-known text then is that we can more easily, it's easier to extract that and utilize it in kind of classic geospatial environments. There are, however, a range of approaches, and we document those here, that you can use to associate things. So if you wanted to make associations with GeoJSON files or other types of resources, you could also do that here, and we've documented out these approaches. This is a open set of data. It's on our GitHub site. And so if you have questions or issues or concerns about these, please open a GitHub issue on that, and we can address it that way. It very much is a community process of developing these guidance documents for utilization. So we see there some ideas of how to address those types of spatial elements in there. I did want to highlight just a couple others if I could. This was a good one I wanted to kind of talk about, because it talks very much about this idea of interconnecting resources, right? So in this case, I've created a type map and I've created a region Guam. Now forgive me for this demo. I did just put a geo point for Guam, but I actually came down here though and tried to get something a little bit more detailed. A geosparql has geometry, as we just saw in the previous section, for a polygon around that particular region. But these two aspects are not what I wanted to highlight here. What I wanted to highlight here is that we can begin to also connect this type of resource out to other things on the net, right? So for example, I could connect it to a marine regions descripting landing page about that particular site. I could also connect it to a Wikidata site associated with Guam. And really what I just wanted to highlight here was, again, this aspect of the graph that we can begin to use to interconnect resources from various partners in this environment. And so it allows that kind of serendipitous discovery, right, through other vectors beyond just spatial for these types of resources. And the knowledge graph that's created out of this collection is a shared knowledge graph for anyone to utilize. And we have documentation at the Ocean InfoHub site about ways that you can query that and other things. And even though the search portal that I showed you is really just a development site that's likely to go away, the JavaScript behind it is quite simple. And the website itself is all at the GitHub site. So if you were interested in looking at that and seeing how that particular search was done, and even how we took those results and broke them down and displayed them, that information is all at the GitHub site. So what I've done is gone over very briefly some of the aspects of the graph. We talked a little bit about the type map as more of a document type environment. We've talked a little bit about the spatial geometry approaches to integrating that kind of information into a resource on the web. And I hope given a little bit of an example about how we can begin to utilize that in a search type environment. I see I'm at my 15-minute mark, so I'll stop there and turn the session back over.